Good day, everyone. We're going to be tackling the topic of problem solving and reasoning for this video. So, in this specific topic, we're going to be relying on our comprehension skills, on how do we usually solve problems on a numerical basis or like a scenario. Because in problem solving, we usually use the numbers itself, but in reasoning, those are the different scenarios that usually we apply our sense of comprehension and our reasoning itself. So, I'm Kevin A. Villarama. I am a Bachelor of Arts in Communication major in Broadcasting. I am from Broadcasting 1B, and I'm going to be assisting or will be helping you understand this topic. So to start this topic, we're going to be heading to the reasoning first. So, reasoning, from the word reason, usually we know this as a idea or a constructed conclusion, or like it is a statement that is formed from a committed action. It is an act of thinking about something in a logical or in a sensible way. It is how we provide a support or a supposition to arrive to a conclusion, which is correct. We usually use our reasoning as a basis for us to create the conclusion that we will do, or like what is the solution that we have to manifest, or like what is the conclusion or the result of that specific actions that we did or the reasons that we created. For example, is that John bought 3 lottery tickets and showed it to his friends, telling that he will immediately resign if he win. After a week, his friends infer that he won because John resigned from his work. So clearly in that example, John brought 3 lottery tickets and showed it to his friends, telling that he will immediately resign if he win. And after a week, his friends infer that he won because John resigned from his work. So if John resigned from his work, automatically, we already know that he won the lottery, because that is the condition of the example that was given. Because if he win, it said that he will resign. And after a week, there's no sign of John because he resigned. And we can conclude that he won the lottery. Is it clear? In that example, we also have 2 things that we need to remember. First is the premise, and second is the conclusion. The premise is like usually the first part of the reasoning itself. First part is that John bought 3 lottery tickets and showed it to his friends, telling that he will immediately resign if he win. And after that, the premise, we arrive to the conclusion itself, which is the after a week, his friends infer that he won because John resigned from his work. That is the conclusion. Because why did John resign? Because he won the lottery itself. That is the conclusion. Again, that is, we have 2. We have the premise and also the conclusion. In reasoning, we have to discuss the inductive reasoning and the deductive reasoning. So first, inductive reasoning is the process of making a general conclusion based on a specific and detailed examples. In inductive reasoning, what you want to remember is that it is from a general idea to specific results. That is the only thing that you have to remember in inductive reasoning. But in inductive reasoning, we have what we call the conjecture. The conjecture or the conclusion form is the conclusion that is formed from the inductive reasoning itself. So, for example, I will give you an example. Men like blue. So therefore, my friend Mark likes blue. The general idea there is that men likes blue. And then the specific result is that my friend Mark likes blue. The conjecture on that example is that Mark likes blue. Why? Because it may be true or it may be false. So what you want to remember in a conjecture is that it's either true or it's either false. But it is also considered as a conclusion. That is in inductive reasoning. In inductive reasoning, it is from a general idea to specific results. So from a general idea, which is all men likes blue, and a specific results is that my friend Mark likes blue. And if you combine them, all men likes blue, therefore my friend Mark likes blue. But it depends on the factuality on how do you prove that Mark likes blue, because conjectures or the conclusion formed in this kind of reasoning is dependent on the situation itself. But in either way, it is considered as conclusion. So let me give some examples. Every object I release from my hand falls to the ground, therefore the next object that will release from my hand will fall to the ground. Every object I release from my hand falls to the ground. That is the first part, which is the premise, and therefore the next object that will release from my hand will fall to the ground. Therefore, every object that will release on my hand will fall to the ground, which is a statement or a fact that is already proven. But either way, if it's still not proven, it's still a conclusion itself. But in real life, if we are going to apply the knowledge that we already have, it is already a fact because we have gravity, right? So in every object that I release from my hand to the ground, therefore the next object that will release from my hand will fall to the ground. The general idea is that every object that I release in my hand will fall. Like, it's a statement that every object that I put in my hand, or like I release it, it will fall automatically. That is the general idea. The specific idea is that the next object I touch or like I put in my hand that I will release will automatically fall to the ground if I release it. That is the specific idea. So from general idea to specific results. The next example is the next number to the sequence is 4, 8, 12, 16 is 20. So we can use the 4, 8, 12, 16 as a base to create the conclusion of what is the next number in the sequence. So if we are going to analyze the pattern 4, 8, 12, 16, we can clearly decipher that it is an addition of 4. So 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16, and 4 plus 16 is 20. So that itself is an example of a inductive reasoning because we use the set of present numbers or like the set of the current numbers that we can see as a base, and we use that to trace the patterns to create what's going to be the specific result of the next number in the sequence. So we knew that it's going to be 20 because it gave us a pattern to follow. And that is an example of inductive reasoning. So to recall, in inductive reasoning, you just have to remember that it's from a general idea, like it's from a generalized thought, and the result will be always specific. Okay? And next, we have to proceed to the deductive reasoning. In deductive reasoning, it is a process of making conclusions based on these general principles to specific ideas. So, or like specific results. In deductive reasoning, it's the complete opposite of the inductive reasoning. So in deductive reasoning, we have to remember that it is from a specific idea to general results. In deductive reasoning, it is it's like a different take on the inductive. It's like the opposite ones. If in inductive we're going to be going from general to specific, we go from specific to general. That's how we go on deductive reasoning. For example, is that all men are mortal. I am a man, therefore I am immortal. So the specific idea here is that I am a man. That is the specific idea that we can see on this example. And all men are mortal. That is the general thought. Then the conclusion itself, therefore, I am a mortal. Because from the specific given is that I am a man. And it said that all men are mortal. Therefore, we can create the conclusion that I am a mortal because it is said specifically that I am a man. Okay? Next is if 6x is equals to 12, then x is equals to 2. So if we analyze the equation itself, we can use the product, which is the 12, as a divisor to the 6 for us to be able to get what is the multiplier here. But if we are going to analyze, we have to think of a number that if we multiply in 6, the answer is going to be 12. So basically, if we think about that, 6 times 2, it is equals to 12. Then we proceed to the answer of 12. In this example, we are given with the specific given itself, which is the 6x. So the specific result is 12. That is the specific result, which is 12. So if we think about it, 6 divided by 12 is equals to 2. But if we multiply the 6 into 2, it's going to be resulting into 12. So that's how it works in deductive reasoning. So in deductive reasoning, we must remember that it is from a specific idea to a general result. And in inductive reasoning, we need to remember that it is from a general idea to specific results. Okay? Now we proceed to a problem solving, which is the Polya's 4-step strategy in problem solving. So in Polya's 4-step strategy, we start from the step 1, which is the understand the problem, which is, of course, we need to understand the problem itself before we solve it. What is missing, or like what do we need to find? What is the equation itself? What is the question that is being asked on the problem? Then next is you have to devise a plan. Of course, after you understand the problem and you know what is the question, what is something that you need to find, you have to devise a plan for you to be able to find what is in the question itself, or like what is the problem, what is the problem that you need to solve. You have to devise a plan for you to be able to come up with a solution. Next is you have to carry out the plan itself. Of course, if you map out a plan, you'll be able to carry it out. You should be able to follow the steps. You should be able to use the plan that you created for you to be able to see, or for you to be able to reach the final of your plan, or like reach the expected result of the plan that you created, for you to be able to come up with the correct answer itself. And after that, we proceed to the last step, which is the number 4, is review your solutions. Of course, after you perform the solution itself, you have to check if it's correct. You have to check if it's the right process that you did, and it's for corrective measures that you have manifested the right answer that you created. So yeah, we have the 4-step itself: the understand the problem, the devise a plan, number 3 is carry out the plan, and lastly is the review your solution. So let us apply it in a problem. Here is a sample problem. The product of the ages in years of the 3 teenagers is 4,590. None of these teens are of the same ages. What are the ages of the teenagers? So before we proceed to the 4 steps, we have to understand the problem itself. Okay, so the product of the ages in years of the 3 teenagers is 4,590. So there are 3 ages that are present here, 3 teenagers, and the product of those 3 ages is 4,590. And none of these teenagers are the same age. So those 3 ages are different from each other. So what are the ages of the teenagers? So we have to find the 3 ages of the teenagers. Let us use the Polya's 4 steps strategy in problem solving. So first is understand the problem. The ages of the teenagers range from 13, 14, 15, 16, 17, 18, and 19. From this range, we pick 3 of which the product 4,590, but remember, none of the teenagers are of the same age. So we understand the problem. Now we have to choose what are the ranges what are the range of ages that we have to choose. Like we need to scale out the ages that we think are the ages of the three teenagers that are being identified in the problem. So we picked 13 to 19. So next is devise a plan. Represent the three ages by x, y, and z. That is x multiplied by y multiplied by z is equals to 4,590. Now, since 4,590 ends with a 0, the divisors or the factors end in 0, 2, or 5. But clearly, we do not have a 0 or a 2 in a range of the ages that we pick. Automatically, 15 is going to be one of the age that is present on the three teenagers. So, we can carry out the plan. Like, we can use the process of elimination since we have the lead of 15. So, we can use 15, 16, and 18. We can use 15, 16, and 19. We can use 15, 17, and 18. So, as you can see here on the PowerPoint, 15 times 16 multiplied by 18 is 4,320, which is wrong. Next is the 15 multiplied by 16 multiplied by 19 is 4,560, which is wrong. 15 multiplied by 17 multiplied by 18 is equals to 4,590, which is the correct answer that we are finding. So therefore, the ages of the teenagers are 15, 17, and 18. So lastly is that we proceed to the reviewing of the solution itself. So we can check if that 15, 17, and 18 is the correct factors of the 4,590 product. So clearly we can use calculators to multiply it and correct it if it's not, but to review your solutions, you have to perform the right operations. Solution, we use multiplication, so we are going to be using times. So 15 times 17 times 18 is 4,590, and therefore we get the right set of ages, which is 15, 17, and 18. And that is how we use the Polya's 4-step strategy and problem solving. It's not that hard, right? You just have to follow the rules. It's basically how you do usually how you solve math equation. You just have to map it out technically and follow the step of Polya. So yeah, that is the problem solving and reasoning topic, and I hope that you have learned something, and I hope that I explained it as I can to make it clear and concise. And yeah, thank you so much for listening, guys.